Group chats run on unwritten rules. You join a conversation, and within a few messages, you intuitively pick up on whether this group values directness, deflects praise, avoids apologies, or treats bad news with dry humor rather than sympathy. These local social norms aren't stated explicitly. They're inferred from precedent. And right now, if you ask a large language model to step into that kind of multi-party chat, it will almost always default to a generic, politely helpful assistant persona, completely missing the local rhythm. That's the exact problem the LoSoNA benchmark was built to measure. LoSoNA stands for Local Social Norm Adaptation. It's a controlled evaluation framework designed to test whether frontier and open-weight models can infer implicit conversational rules from a group transcript and adapt a single-turn response accordingly. The paper introducing it comes from Hume-like research, and it tackles a gap that's been largely ignored in social AI evaluation: multi-party, single-turn, norm inference under zero explicit instruction. To understand why this matters, we need to look at how social capabilities have been benchmarked so far. Earlier work like Social ICA or Satopia focuses on dyadic interactions, explicit private goals, or multi-turn goal completion. They measure whether an agent can navigate a social scenario or achieve a stated objective. But real group chats don't work like that. You aren't given a mission. You aren't playing against a partner. You're just trying to say the right thing in the right way, based on what the group has already established. LoSoNA strips away the noise. It isolates one specific capability. Can the model observe precedent, infer a hidden local norm, and comply with it in a single response? The benchmark is built on a structured tuple system. Each scenario is generated from a pair, an event type, and an implicit social norm. Not every combination makes sense, so they apply an applicability filter. For example, a norm about deflection of praise only applies to event types like achievement announcements or birthday rituals. Once a valid pair is selected, the generator constructs a multi-party chat transcript. The transcript includes sparse demonstrations where non-subject participants naturally follow the hidden norm, followed by a final elicitor turn. That elicitor is carefully designed to be diagnostically ambiguous. A generic assistant response will usually breach the target norm, but a locally adapted response will comply. The subject model never sees the norm label, the generator's private notes, or the intended conversational goal. It only sees the chat, and it has to figure out what's expected. During curation, they run a strict no-demonstration control. For every candidate scenario, they test a baseline model under naive prompting. If the baseline already answers compliantly without seeing precedent, the scenario is discarded. You only keep scenarios where default assistant behavior would actually violate the local expectation. This ensures that success requires genuine inference, not just model bias toward politeness. The evaluation protocol is tightly controlled. Each scenario is rendered under 4 distinct prompt conditions. The naive prompt just asks the model to reply as the subject persona. The elicitor-only condition restricts the model to responding only to the final message, treating earlier turns as plain context. The style adaptation prompt softly encourages fitting the local tone and relationships without naming norms. And the norm-informed condition explicitly warns the model that a repeated local pattern or norm may be present in the conversation. All 4 conditions hide the target norm from the subject. Every response is scored by a fixed LLM judge. They use Gemini 3.1 Pro preview at temperature 0, which receives the transcript, the elicitor, the target norm statement, and illustrative compliant and breaching examples. The judge follows a strict decision procedure. It identifies what the elicitor invites, maps it to the norm requirement, checks for required or banned behaviors, and outputs a compliance label. They sample 3 responses per scenario per condition, and report accuracy at 3, which is simply majority vote over those 3 trials. Confidence intervals are computed by bootstrapping over scenarios, not over raw model calls, which is the correct approach for a small, curated benchmark. They tested 8 models: GPT-5.5, Claude Opus 4.8, Claude Fable 5, Gemini 3.1 Pro, QN2, 5-72B, Llama 3.370B, Mistral Medium 3.1, and Gemma 327B. The results reveal a stark divide in how models handle implicit social inference. Under naive prompting, most models sit between 21 and 47% accuracy. They default to generic helpfulness, which actively breaches norms like binary answers, non-affiliative support, or banned enthusiasm. Soft prompts like elicitor-only or style adaptation don't consistently move the needle. The real signal comes from the norm-informed condition, and even then, the effect is highly model-specific. Gemini 3.1 Pro jumps by 47 percentage points, landing at 84% accuracy. Claude Fable 5 gains 34 points, hitting 81%. Claude Opus 4.8 and Gemma 327B each improve by roughly 10 points. But here's where it gets interesting. Explicit norm-aware prompting isn't a universal upgrade. GPT-5.5 barely moves. QN2, 5-72B stays flat. Mistral Medium 3.1 actually regresses by 10 points, and QN drops further. When they break down the norm-informed prompt into recovered failures and introduced regressions, the pattern becomes clear. Gemini and Claude Fable 5 recover the vast majority of their naive failures without breaking previously successful responses. Mistral and QN, on the other hand, introduce significant regressions. They seem to over-index on the hint, disrupting otherwise compliant responses or misaligning the inference strategy. This suggests that the ability to use a metacognitive prompt about local patterns isn't just a function of scale. It's tied to how the model allocates attention to precedent versus default instruction following priors. The benchmark also breaks down by norm type and event type. They test 22 distinct norms, ranging from bystander intervention and mandatory risk identification to banned direct answers and mandatory irony. The distribution isn't uniform, because the curated set prioritizes interpretability over coverage. But the per-norm breakdowns already show which behaviors are easiest or hardest for models to infer. Non-affiliative support, where a group expects diagnostic or practical uptake instead of sympathy, is particularly challenging for models trained on broad helpfulness alignments. Bystander intervention, where the group expects a member to defend a target of direct criticism, is more frequently recovered under explicit prompting. There are important limitations to acknowledge. The benchmark is synthetic, English only, and currently limited to 38 human-curated scenarios. Real group chats contain overlapping norms, role-specific expectations, threading, media, long-term memory, and multi-turn repair. LoSoNA deliberately abstracts all of that away to isolate single-turn adaptation. The no demonstration screening was done using a Gemini 3 Pro preview baseline, which means Gemini family results should be interpreted with that construction choice in mind. The filter may have inadvertently selected elicitors that Gemini family defaults tend to breach, which could inflate their apparent headroom. They also ran sanity checks. A manual audit of 100 judged responses showed 85% agreement with human labels, and rescored the entire sweep with Claude Opus 4.8 as an alternate judge, which preserved the main qualitative patterns. Still, LLM judging introduces family bias, and larger human validation will be necessary as the benchmark scales. Looking ahead, the authors plan to expand the scenario set, test multiple languages, incorporate naturally occurring chat data where privacy allows, and eventually introduce dynamic benchmarks where agents face multi-turn sanctions and adaptation. The immediate takeaway, though, is clear. Current frontier models are not reliably inferring local social norms from precedent. Naive prompting leaves them stuck in generic assistant mode. And while explicit meta-prompts can unlock massive gains for some architectures, they expose fundamental differences in how models weigh instruction following priors against contextual pattern recognition. If you're building social agents, evaluating alignment, or just trying to understand where LLM social reasoning actually breaks down, LoSoNA gives you a clean, reproducible lens. It shows that social adaptation isn't just about having more parameters. It's about how the model processes implicit precedent, how it handles diagnostic ambiguity, and whether it can suppress its default helpfulness when the local context demands something else entirely. The benchmark is already released as a Hugging Face dataset, and it's a solid foundation for the next wave of multi-party social evaluation. If you want to dig into the full prompt templates, judge decision procedures, or the complete accuracy tables with bootstrap intervals, the dataset and paper are linked below. Let me know in the comments which model you think will crack the harder norms first, or if you've seen similar behavior in your own deployments. I'll see you in the next one.